Hello. Hello, everyone. So this is the fifth episode of my mentorship session. Okay. So in this episode, we will be covering the relationship between the base or quote currency and its associated exchange rate. So we're gonna be covering, in short, we're gonna be covering the relationship of base currency or base commodity with its exchange rate. Okay. And the relationship of quote currency with its exchange rate. Okay, so let's read through this document, and we're gonna cover the details in this video. So understanding the relationship between currency exchange rates and currency is fundamental in forex trading. Here is an explanation of how the base and quote currencies uh, quote currencies relate to exchange rates. Okay, so base currency. Okay, so the base currency is the first currency listed in a currency pair. It represents the currency being bought or sold. Okay. The value of the base currency is always 1 unit. In a currency pair, the base currency is directly proportional to the exchange rate. Okay. This means that if the price of the base currency increases, then the exchange rate also increases in value. Conversely, when the price of the base currency decreases, then the exchange rate also decreases in value. All right. So we must keep in mind that the base currency is always directly proportional to the exchange rate. Okay. So what does directly proportional means? The directly proportional means that when the price of the base currency increases, okay, then the price of the exchange rate will also increase. And the quote currency is the second currency listed in a currency pair. You already know that we have covered this in our previous episodes. It represents the currency in which the price of the base currency is quoted. Okay. In a currency pair, the quote currency is inversely proportional to the exchange rate. This means that if the price of the quote currency increases, then the exchange rate decreases in value. Conversely, when the price of the quote currency decreases, then the exchange rate increases in value. Okay. Now, the relationship between the base, okay, and now we're going to cover the relationship between the base commodity and quote currency with its associated exchange rate. It is very similar to the base currency. Okay. So we're going to cover it now. Understanding the relationship between currency exchange rates and currency is fundamental in forex trading. Here's an explanation of how the base and quote currencies relate to exchange rates. So first of all, we gonna cover here the base commodity. Okay, previously we covered base currency, but here we're gonna cover base commodity. All right. The base commodity is the first currency listed in a commodity pair. You already know this. Okay. It represents the commodity being sold, bought, or sold. The value of the base currency, the value of the base commodity is always 1. In a commodity pair, the base currency commodity is directly proportional to the exchange rate. This means that if the price of the base commodity increases, then the exchange rate also increases in value. Conversely, when the price of a base commodity decreases, then the exchange rate also decreases in value. I'm going to explain you this graphically in a very, very simple manner later on in this video. So quote currency. The quote currency is the second currency listed in a commodity pair. Okay. It represents the currency in which the price of the base commodity is quoted. In a commodity pair, the quote currency is inversely proportional to the exchange rate. Remember this. This means that if the price of the quote currency increases, then the exchange rate decreases in value. Conversely, when the price of the quote currency decreases, then the exchange rate increase in value. So it's opposite, okay? We have an inverse relationship. Now, the figure given below demonstrates the relationship between base currency or base commodity and exchange rate, and the relationship between quote currency and exchange rate. Okay, we're going to study these diagrams in detail now. So first of all, let me explain you this entire text in like graphically. All right. So we're going to switch to the whiteboard now, and I'm going to just share with you. All right. So we have, let's suppose we have the base and core currency. We have base currency. Okay. We can write, let me take an example of base currency and core currency. Let's suppose we have euro slash US dollar. Okay. So euro slash US dollar. Now we have to study the relationship. Okay. We have to study the relationship of euro, which is a base currency, and we have to study the relationship of USD, which is the core currency in this example. Okay, so we have to study the relationship between euro USD and its exchange rate. Oh, sorry, we have to study the relationship between euro and euro USD exchange rate, and we also have to study the relationship between USD and euro USD exchange rate. So what is the relationship? Okay, okay, all right. So remember that, as I told you, that base is directly proportional to the exchange rate. Okay. Quote is inversely proportional to the exchange rate. Now, what does this mean? For example, we have Euro USD example here. So let's suppose we have Euro here, okay, and we have Euro USD. We're going to study the relationship between them. All right. So when the price of the Euro goes up, okay, the price of the Euro USD exchange rate will also go up. All right. And when the price of the Euro goes down, then the price of the Euro USD exchange rate will also go down. Why? Because base currency is or base commodity is directly proportional to the exchange rate. All right. So this is the relationship. Okay. Now the quote currency is inversely proportional to the exchange rate. Now let me show you. Okay. Let me give you example here. We have US dollar, because in this Euro USD is a quote currency. So we're going to write down USD. Okay. And we need to study the relationship of USD with Euro USD exchange rate. Okay. Now, when the price of the US dollar goes up, because we have an inverse relationship, so when the price of the US dollar goes up, then the price of the Euro USD exchange rate will go down. Okay. Similarly, when the price of the US dollar goes down, then the price of the Euro USD exchange rate will go up. That's why we call it as inversely proportional. Okay, this is the inverse relationship. All right, so far you have got this idea. So read the text again, see this video again, and see this specific portion of the video, and you will understand what I mean to say. In the same way, we can also take an example of Euro US, XAU USD. Now, let's suppose we take an example of commodity pair. Okay, commodity pair. In a commodity pair, we have base commodity, and we have uh, quote currency. Okay, so we have a base commodity and quote currency. An example of commodity pair is XAU slash US dollar. This is gold. Okay, gold US dollar. So this is obviously the base currency, and this is quote currency. US dollar is a quote currency, and XAU, which is also known as gold, it is a commodity, base commodity. All right. So we know that base commodity is directly proportional to its exchange rate. Okay. And quote currency is inversely proportional to its exchange rate. Okay. So let me give an example here. Now we have XAU as a base commodity and US dollar as a quote currency. So what does this mean? We're going to take first of all base currency, okay, base commodity, which is XAU, okay, and we're going to compare it with uh, XAU slash US dollar exchange rate. So we're going to compare the gold with its exchange rate. So when the price of the gold or gold commodity, when the price of the gold goes up, okay, then the price of the XAU USD will also go up. Why? Because base commodity is directly proportional to its exchange rate. Okay. Okay. So now we're going to compare. Okay. And let's go further now. Okay. So when the value of the gold goes down, then the value of the XAU USD exchange rate also goes down. Why? Because base commodity is directly proportional to its exchange rate. Okay. Now we're going to look towards the US dollar, which is the quote currency, and its relationship with XAU slash US dollar exchange rate. So you know that the quote currency is inversely proportional to its exchange rate. So what's going to happen when the value of the quote currency, which is US dollar, goes up, then the value of the exchange rate goes down. Okay. Similarly, when the value of the US dollar goes down, which is a quote currency, then the value of the exchange rate goes up. Okay, because the quote currency is inversely proportional to its exchange rate. Okay, so this is the relationship we have to keep in mind. Okay, now let me give you a generalized formula. Okay, now we have the base commodity. Okay, commodity, and here we have exchange rate. So you know that the base commodity is directly proportional to its exchange rate. This means that the value when the value of the base commodity goes up, then its exchange rate also goes up. Okay. Similarly, when the value of the base commodity goes down, then its exchange rate will also go down. Okay, because the base commodity is directly proportional to its exchange rate. Now we're gonna compare base currency and its exchange rate. Okay. Now you know that both base commodity and base currency are directly proportional to its exchange rate. This means that when the base currency goes up, when the value of the base currency goes up, then the exchange rate will also go up. Okay. Similarly, when the value of the base currency goes down, then the value of its exchange rate will also go down. Why? Because base commodity or base currency is directly proportional to its exchange rate. Okay. Now we're going to see the quote currency. So, okay, this is a generalized formula. Now quote currency, and we're going to compare the quote currency's relationship with its exchange rate. So you know that quote currency is inversely proportional to its exchange rate. This means that when the value of the quote currency goes up, then the value of the exchange rate goes down. And when the value of the of the quote currency goes down, then the value of the exchange rate goes up. Why? Because quote currency has an inversely proportional relationship with the exchange rate. Okay, this is a generalized idea. You have to remember it. Okay, now we're gonna go back to our document. Okay, now we have to follow through these. Now we have to understand what is direct proportion and what is inverse proportion. I will give you a very basic explanation of direct proportion and inverse proportion. So I'm gonna zoom in this chart so that you can see it. Now, now we're going to understanding the direct proportion. Direct proportion is the direct relationship between two variables such that when the value of one variable increases, then the value of another variable also increases, as I told you before in this video. Why and vice versa. Vice versa means that when the value of the one variable decreases, then the value of another variable will also decrease. Okay. Direct proportion is denoted by the following formula. X1 divided by Y1 equals to X2 divided by Y2. Okay, now this is an example. This is a graph of the direct proportion. You can see the graph. Okay, this is a graph of the direct proportion. Direct proportion graph can be drawn between variable X and Y, and it can either be drawn like this or it can be drawn like this. Okay, so both graphical representations are possible. Okay, they are all right. Okay, for now I will give an example. For instance, two apples cost at $210. Find out the cost of apples if the apples are 4 or if the apple is 1. Now, what does this case scenario shows us? This case scenario tells us that the cost of the two apple is $10. Now we have to find the cost of the 4 apples, and we also have to find the cost of the 1 apple. How are we gonna do that? Okay, when we increase the number of apples. Now I'm gonna solve this equation. Okay, in front of you. So cost of 2 apples. Okay, so 2 apples cost $10. Now we have to find out cost of 4 apples. Okay, what is the cost of 4 apples? Okay, we are given that the 2 apples cost $10. Now we have to figure out the cost of the 4 apples. How are we going to do that? Now just imagine and just understand and just observe. Okay, when okay, 2 apples cost $10, and when we increase the quantity of the apple, so obviously the price of the apple will also increase. So we can say that apple quantity is directly proportional. Okay, apple quantity is directly proportional to its cost. Okay, so this means when the quantity of the apple increases, then the cost of of those quantities will also increase. Apple quantities will also increase. And when the quantity of the apples decreases, okay, then the cost of those quantified apples will also decrease. Okay, this is a very basic observation. Okay, now we can draw a simple observation here. Apple cost. So we can say that when the quantity of apple increases, then the cost of total apple will also increase. Okay. Similarly, when the quantity of apples decreases, then the cost of the of the of the quantified apples will also decrease because they are in direct proportional relationship. All right. All right. So we will solve this question now. How we solve this question? As we know the formula is very simple. As I told you, x1 divided by y1 is equals to x2 divided by y2. So this is a formula. We have to put this equation into this formula and figure out our answer. So what we're going to do, we're going to figure out our answer. So x1 is, so we're going to just draw it like this. Okay. This is x1. Okay. And this is y1. All right. This is x2 and this is y2. All right. So we're going to plug this entire variables into the formula. All right. So we can say x1 is equals to 2, y1 is equals to 10, x2 is equals to 4, y2 is unknown. 4, y2 we don't know. All right. We don't know the value of y2. We need to find out the value of the y2. All right. So how are we gonna find it? Okay, we're gonna place this into the formula. So first of all, we're gonna write down the formula like this. We have x1 divided by y1 equals to x2 divided by y2. Okay, now we're going to plug the value. So once we plug the value, so x1 is equals to 2. Okay, y1 is equals to 10 equals to x2 is equals to 4. All right, y2 is equals to y2. We don't know the value of y2. So we need to figure out the value of y2. So how are we gonna we gonna do that? 2 divided by 10 okay equals to 4 divided by y2. All right, what we're gonna do, we're gonna cross multiply. Okay, we gonna cross multiply. So what gonna happen now? So 2 multiply by y2, so it will be 2 y2 is equals to 10 into 4. All right, so we're gonna divide it like this. 2y2 is equals to 40. Now we need to figure out the value of y2 now. So y2, so if this is multiplying here, if we send it over there, it will be divided. So we can say 40 divided by 2, and the answer would be 20. So what is the value of the 4 apples? The cost of the 4 apple would be 20 US dollar. Okay. So this is the direct proportion. Now I'm gonna move on to the second part of this question, and we're gonna see how we can test it out. All right. So we're gonna go back to our document, and now it says that we have to find the value of the 1 apple or the cost of the 1 apple. How are we gonna find it out? So we go back to the whiteboard, and here we're gonna change it to 1 apple. Okay, so how are we gonna do that? It's very simple. First of all, we need to figure out the value of x1, y1, x2, and y2. Okay. So we're gonna figure out the value of x1. The value of x1 is 2, and the value of y1 is 10. The value of x2 is 1, and the value of y2 is unknown. We don't know. Okay. So we need to find the value of the x1, sorry, y2. So how are we going to find out? It's very simple. So we're going to just put in the value. Sorry, we're going to just put the functions now. X1 divided by y1 equals to x2 divided by y2. Now we're going to plug the value. X1 is equals to 2, y1 is equals to 10, x2 is equals to 1, and y2 is equals to, we don't know. So we're going to just write it down as y2. Now we're going to cross multiply. Okay. So y2 will be multiplied by this one. So it will become 2y2 is equals to 10. And now we're going to find the value of y2. So you know that y2 is multiplied by 2. And when we send y2 after the equals to sign, it will be divided by 10. Okay. So y2, 10 divided by 2. And the answer would be 5. Okay. So what does this show you? This tells you that when the quantity of the apple increases, then the price of the total apple will also increase. And when the quantity of the apples decreases, then the price of the total apple will also decrease. All right. So this is the direct proportion relationship. Now we're going to go back to our document. Okay. We have done this all. You can read this entire document again. And if it's unreadable, you can just increase the size and read it out. Okay, you can read it out. Okay, now we're gonna study we're gonna dig deeper into direct proportion, and we have to understand how this direct proportion applies to the exchange rates. Okay, so direct proportion is usually represented by, let me increase the size of, like, let me zoom in now. So direct proportion is usually represented by the following formula, as we know that x1 divided by y1 equals to x2 divided by y2. Direct proportion is also represented by the following formula. Constant k is equals to x divided by y. Okay, it's very simple. The formula is constant k is equals to x divided by y. For instance, let's take an advantage. Let's take the exchange rate of euro US dollar into consideration. Euro divided by US dollar is also equals to euro USD exchange rate. Now, I'm gonna just explain you in this whiteboard. Okay. So as we know the formula of the direct exchange, as we know the formula of the direct proportion. Okay. So the formula of the direct proportion is very simple. Okay. Let's suppose we have euro US dollar. Okay. Now we can rewrite. Okay. And the formula of the direct proportion is constant k is equals to okay, constant k is equals to x divided by y. Okay, so what we're gonna do, we have to implement this formula into this. We have to incorporate or integrate this exchange rate, okay, into this formula. So what we're gonna do, so it's very simple. First of all, you're gonna write down euro US dollar exchange rate. Okay, euro US dollar exchange rate means we can also write it down like this. EUR divided by US dollar is equals to EUR slash USD. Okay. So we can rewrite euro US dollar like this. Euro divided by US dollar is also equals to euro US dollar exchange rate. Okay. So now what we're going to do, we have to make US dollar as the subject because we have to compare the base currency, okay, with the exchange rate. So we have to make US dollar as a subject. And okay, so what we're going to do, and we also have to change US dollar to constant K, to constant K. Okay, so what we're going to do, euro divided by K is equals to euro US dollar. Now what we're going to do, we're going to cross multiply. We're going to cross multiply now. So it will be K dot euro. K is multiplied by euro. And at that side, what we have, I did a little bit of mistake here. So what we have to do, we have to make US dollar as constant. So we can write it like this. Euro divided by K is equals to euro slash USD. Okay. So what we're going to do, we're going to place K over here. Okay. And we're going to send euro US dollar to here. All right. Mathematically. So it will become euro divided by euro slash US dollar. Okay. And it will become K. So this is a direct proportion. As I told you, this is a direct proportion. Constant K is equals to X divided by Y. Constant K is equals to X, which is euro. Okay. Y is euro USD exchange rate. All right. Very, very simple. So how are we going to write it down mathematically? Okay. We can say that euro, okay, it is directly proportional. This is a sign of the directly proportional mathematically. It's directly proportional to euro US dollar. Okay. So euro is directly proportional to its exchange rate. Okay. So I have mathematically proven that base currency is actually directly proportional to the exchange rate. So when the value of the base currency goes up, then the value of the exchange rate also goes up. When the value of the base currency goes down, then the value of the exchange rate also goes down. Now, let's go for the inverse proportion. So we're going to write it down again. Okay. So what is the formula for inverse proportion? The formula for inverse proportion is very simple. Constant K is equals to x1 multiplied by x multiplied by y, or we can also call it as xy. So x multiplied by y, we call it as constant K. So constant K is equals to x multiplied by y. So this is a formula for inverse proportion. What? Inverse proportion. All right. So how are we going to interpret this one? Now we have to rewrite this again, and we need to check the relationship of US dollar with the exchange rate. So what we're going to do, very simple. First of all, we have to write down this again. Okay. Euro divided by US dollar, it is equals to euro slash US dollar. Okay, euro divided by US dollar is equals to its exchange rate. Now we have to make euro as a subject, constant K. So what we're gonna do? We're gonna do like this. K, constant K divided by US dollar, and we're gonna make it equals to USD. Okay. So constant K divided by US dollar is equals to euro USD. Now we have to leave this. Now we have to make K as a subject. Now, how to make K as a subject? We're gonna move US dollar from this denominator to here. Okay. So what will happen? K is equals to euro slash US dollar multiply by USD. Okay. Now we have this relationship. Constant K is equals to X multiplied by Y. So constant K is equals to exchange rate multiplied by US dollar. So euro USD is X, Y is US dollar. Okay. So it's very simple. In this way, we call this as that euro USD, sorry, US dollar is inversely proportional. Quote currency is inversely proportional to the exchange rate. It has been proven, okay, mathematically. All right. So we can write down like this. USD, or you can say quote currency, which is, let's suppose USD, it is inversely proportional. Now, this is a sign of inverse proportion, okay, mathematically. So quote currency US dollar is inversely proportional to exchange rate, which is euro USD. All right. So this has been proven. And this is what I have shared here. Now, this is what I have shared here. Okay. Inverse proportion. All right. So you have to read out this, and I've also given the example of these workers, like 4 construction workers build the bridge in 8 days. Okay. So find out in how many days will the bridge be completed if there are 8 workers. Now, this is a very, very interesting topic now. Now we have to understand the inverse proportion. Inverse proportion is the inverse relationship between two variables, such that when the value of one variable increases, then the value of another variable decreases, and vice versa. Vice versa means that when the value of one variable decreases, then the value of another variable will increase. Okay, inverse proportion is denoted by the formula, as I've told you, x1 into y1 equals to x2 into y2. Okay, or you can also write it like this. Okay, so for instance, 4 construction workers build the bridge in 8 days. Find out in how many days will the bridge be built if there are 8 workers. Okay, so I can just show you right now. So we have 4 workers. Okay, 4 workers build the bridge in 8 days. Okay, so we have now we have 8 workers. So we have to find out that 8 workers will build the bridge in how many days. So let's go to it and whiteboard. So now we have to find out 8 workers. 8 workers will take how many days? Okay, we have to find out like this. Now, this is a very, very simple situation. Now, just imagine if 4 workers take 8 days, then the 8 workers will take more days or less days. Of course, when the workers increases, when the quantity of the worker increase, then the number of days will reduce, because 8 workers will finish the work quickly or more quicker than 4 workers. So this is inverse proportion. Inverse proportion is very simple here. Okay, we say that workers and days. So when the number of workers increase, okay, then they will take less days to complete the work. Okay, this is inverse proportion. or inverse relationship. And when the number of workers decrease, then they will take more days to complete their work. Okay, that's it. It's very simple. Okay, so we're gonna just calculate this now. So we have the formula of inverse proportion. First, we have to determine whether the case scenario is inverse proportion or direct proportion. We have already figured out that this case scenario is the inverse proportion. So we're gonna write down the formula here. We have x1 divided by y1 is equals to x2, sorry, x1 dot y1 equals to x2 dot y2. Okay, so dot here means multiplication. Okay, so this is the formula. We have to put this value into here. Okay, so let's suppose we have four workers. We have four workers, so we're gonna determine the value of x1. X1 is equals to 4, y1 is equals to 8, x2 is equals to 8, y2 we don't know. We have to figure out the value of y2. Okay, we have to figure out the value of y2. So we're gonna put these values into this formula and find out our answer. So it's very simple now. X1 is 4. Okay, multiply by y1. Y1 is 8 equals to x2. X2 is 8 multiply by y2 is unknown. We don't know. So we're gonna find out the value of y2 now. So we know that here we have to make y2 as a subject. So what we're gonna do, we're gonna send this 8 over here. So it's very simple. Okay, 4 into 8. 4 into 8 is 32. 8 for the 32. 32, okay, and 32, and we're gonna divide it by 32 divided by 8. So the answer would be 8 1 the 8, 8 for the 32. So the answer is 4. So here the answer is 4. So it means when we have 8 workers, when we have 4 workers, the work will be completed in 8 days. When there are 8 workers, then the work will be completed in 4 days. This is inversely proportional relationship. Okay. And I've told you that the code currency always have an inverse proportional relationship. Okay. I'm going to prove this to you right now. All right. Okay, so we do the second situation. Here in this situation, that the number of workers are increasing. Now we have to understand what will happen when the number of workers will decrease. Okay, so let me go back here. Now we have to figure out when the number of workers decreases from 4 to 2. Okay, so what will happen? So we have to go back again to our whiteboard, and I'm gonna do this calculation. So now we have to find down the 2 workers. All right, so now we're gonna post the 2 workers. So the value, so we have this formula x1 into y1 is equals to x2 into y2. So the value of x1 is 4, the value of y1 is 8, the value of x2 is 2. So we're gonna change it to 2, and we have to find down the value of y2. So 4 into 8, and here we have to write down 2. 2 into y2. So what we have to do here, 2 is multiplied by y2. We have to make y2 as a subject. So what we're going to do, we have to send this 2 over here. So what will happen? So we can write down like this, 4 into 8, all right? And we have to divide it by 2. And the answer is y2. So 2 on the 2, 2 to the 4, and 2 into 8 is 16. So as you can see, as the number of the workers decrease from 4 to 2, the number of days goes up to 16. Okay, this is the inverse relationship. Okay, similarly, okay, we can also write down the inverse proportion relationship. Okay, there is another formula for the inverse proportion, as I've showed you earlier. This is a second formula. Okay, so this is a second formula of the inverse relationship. X into y is equals to x into y. All right. X dot y is equals to x into y. So constant k is equals to x into y. This is the inverse proportion formula. We have two formulas here, right? For the currency exchange rate, to determine the relationship between the currency and its exchange rate, we need to use this formula. Constant k is equals to x into y. So it's very simple. For instance, let's take exchange rate of Euro USD into consideration. Euro divided by US dollar. So Euro divided by US dollar is also equals to Euro USD, making EUR as constant K and as subject. So we have to make EUR as constant K. So EUR, we make it is K, and we send US dollar from this denominator to here. Okay. So constant K is equals to Euro USD exchange rate multiplied by US dollar. Now we can say that this formula exactly fit this formula. All right. So we can say that USD is inversely proportional to the exchange rate. This means that USD here is a code currency. So this has been proved that code currency is inversely proportional to the exchange rate. So when the value of the code currency increases, then the value of the exchange rate will decrease. And when the value of the code currency decreases, then the value of the exchange rate will increase. Okay. And this is a graphical representation of the inverse proportion. All right. And now I have done this. I have done the same thing. I have shown every step how the base and code currencies are related to the exchange rates. So here we can study it from here. Base currency divided by code currency is equals to exchange rate of base currency, base and code currency. Relationship between base currency and exchange rate. So base divided by code is equals to exchange rate. Make code as subject. We make code as subject. So what gonna happen? So we gonna send code over here, and exchange rate will be sent here. Okay, we will swap the places. Okay, so it will be written like this: quote is equals to base divided by exchange rate. Now we have to make quote as constant k. So we have to replace quote with k. So okay, so k is equals to base divided by exchange rate. So we can say that base currency is directly proportional to the exchange rate. Okay. Now, this is a graphical representation of the base currency and the exchange rate. You have to remember this graphical representation. Okay. As you can see from the graph, when the value of the base currency increases, okay, let me show you here. So when the value of the base currency increases, you can see from here, uh, as the value of the base currency increases, you can see that the base currency, this is the base currency. So the value of the base currency is increasing, and the value of the exchange rate is also increasing, you can see. And when the value of the base currency is decreasing, then the value of the exchange rate, okay, is also increasing. Let's suppose, okay, we have this point 1, and this is point 2. Here, the value of the base currency has increased. So we have a greater value of exchange rate. Here, the value of the base currency is decreased. So the value of the exchange rate is also decreased. You can see over here. Very easy. Okay. Similarly, we can also show it from here. So we take this point and we take this point. Okay. So this is the base currency. When the value of the base currency is decreased, then the exchange rate is also decreased. When the value of the base currency is increased, then the value of the exchange rate is also increased. So this is a directly proportional graph. Okay. Now we're going to go further. Okay. Now, base commodity and code currency. Base commodity divided by code currency is equals to exchange rate of base commodity and base commodity quote currency exchange rate. Relationship between base commodity and exchange rate. Base divided by quote is equals to exchange rate. We have to make quote as a subject. Okay, so what we're gonna do, we have to send quote over here and exchange rate over here. So we have to swap the places according to the formula. So what will happen? Quote is equals to base divided by exchange rate. Okay, base divided by exchange rate. Now we have to make quote as constant k. So we're gonna put k in place of quote. So k is equals to base divided by exchange rate. Now we can simply say, because it is dividing, and I have already told you the formula that constant k is equals to x divided by y. When we have this formula, then there is a direct proportional relationship. So this is a k is equals to x divided by y. So this is a direct proportional relationship. It means that base is directly proportional to the exchange rate. Okay. So what does this show? That when the value of the base currency, okay, when the value of the base currency, so we are gonna take this value and this value. So when the value of the base currency increases, then the value of the exchange rate also increases. Sorry to say, when the value of the base commodity increases, then the value of the exchange rate is also increased. When the value of the base commodity decreases, then the value of the exchange rate also decrease. You can see, it's very simple. Similarly, when the value of the base commodity decreases, then the value of the exchange rate is also decreased. When the value of the base commodity increases, then the value of the exchange rate also increases. Okay, very simple formula. All right. Now we're gonna move to the base commodity or 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 currency, or code currency, okay, and its relationship with the exchange rate. So relationship between code currency and exchange rate. So we have to write down the same formula: base divided by code is equals to exchange rate. Now we have to make base as a subject. So we make base as a subject. We're gonna send code from the denominator to here. So what we are saying here, the quote is dividing with the base. So we have to send it here. So here the quote will multiply. Okay, when we send it here. So it will become like this. Base is equals to quote multiply by exchange rate. Now we have to make base as a constant k. Okay, we have to make it as a constant k. So we're gonna make base as a constant k, and the formula will become quote multiply by exchange rate. Now we have to study the relationship between exchange rate and quote. As I told you, that the formula for the exchange rate is, oh sorry, that the formula for the constant for the uh, inverse proportion relationship is constant k is equals to x multiply by y. Okay. So we have seen this relationship x multiplies, so x is a quote and exchange rate is y. So we can say that quote is inversely proportional to the quote currency is inversely proportional to the exchange rate. All right. Now we have to do the graphical representation of the quote currency and exchange rate. It's very simple. Okay. So what we're going to see here, we can see that when the value of the quote currency is higher, is increased, then the value of the exchange rate decreases. Okay. And when the value of the quote currency is decreased, okay, when the value of the quote currency is decreased, then the exchange rate increases. This is an inverse proportion relationship. In the same way, when the value of the quote currency increases, then the value of the exchange rate decreases. When the value of the quote currency decreases, then the value of the exchange rate will increase. Okay, it's very simple. Okay. Now we have to do Euro USD exchange rate, relationship between US dollar and exchange rate. So you can study these all graphs here, and I suggest you, I have repeated the same thing, but the only difference is that I have used the example of uh, of actual currencies like the commodity pairs or the euro US dollar exchange rate to determine the relationship. Okay. So what you have to do, you have to use this entire document, read it again over and over again, and you will have a clear idea about the relationship between base currency and exchange rate, base commodity and exchange rate, code currency and exchange rate. So you have to study these three relationships. Okay. That's it. So this entire document, this specific section of the document will clarify everything to you. All right. And you also have to understand the graphical representation of this. Okay. So that's it now. Okay. Our episode 5 has been completed, and I gonna see you in the next episode, which is episode number 6.